new equilibrium, these decrease, that increases, and that's it. Okay, so now, stress, I decrease the volume, I increase the pressure, I shift it away from where I'd have more pressure to try to relieve that stress and relieve that pressure into where I have less. So that shifts to the right, this one would shift to the left.
Go back.
Put in those arrows. This is the same system we just looked at.
Yeah.
Decrease the volume, increase the pressure. Pressure moves from more moles to less moles of gas. So it goes from left to right to relieve that pressure.
And then
That would mean this decreases, that increases. If I pull away, if I increase the volume, I decrease the pressure, it's now going to move towards where there was more pressure. So it's going to move from the right to the left. That means this goes down, those go up. That's what you see here.
Isn't that the Born-Haber reaction?
Born-Haber, the term,
I just wanted to ask.
Born-Haber was the,
It's like the cycle, right?
yeah, this isn't necessarily a cycle. This is already this is just an equilibrium reaction, right? And all I'm doing is applying a stress to it. And the specific stress, so the first stress I showed was if I applied a concentration. The second stress I'm now showing is if I apply a pressure to just this system right here. So all I'm worried about is this equilibrium within this chemical reaction. That's all I care about. So based on just this, if I apply pressure to this system. Okay, so are we okay here?
yeah.
Mona,
Yeah.
you have a question about it?
No.
No?
I got it.
Anybody else? No? Okay. Oops. So here I have carbon plus CO2 gives me CO. I have two gases here, so that could apply if I add or change pressure. I have 2 moles and 1 mole, so I have a greater pressure on this side than this side within the same container. Okay? So I have some reactant species, and I have a different mole of both reactants and products. Okay, so then the next thing is I'm going to decrease the volume. When I decrease the volume, that also means I increase the pressure. So if I increase the pressure, it's going to move away from where I have more pressure. So it's going to move from the right to the left. It's going to move from more moles to less moles. So it should shift to the left. Okay? Which means that this increase, that increase, that decrease. And of course, then if I do the opposite, it goes back towards it. It's the same exact thing we just did. Gives you a couple different examples to look at. Look at it as a system. From the system, do I have gases in it? If I do I have a different number of moles on each side? The one that has more moles, you could think of as, you know, one way to do this, because I see a couple people looking a little bit confused. So let me do this for you. The first thing is, make sure you can correlate these two, because I could just ask one or the other, and you're supposed to be able to answer it.
Yeah.
So if I just put this, you should automatically know this.
Right.
Yeah, that I got.
So let's say I have, let's do this, C plus CO2 gives me 2CO. Okay. You might want to just say that, you might just want to put here as plus pressure, meaning that you have a greater pressure here. So now if I add pressure here, you know it will shift that way. Everybody see that?
Yeah.
So wherever the more moles are, you could do it just in your mind. You don't actually have to, or you could write it if it makes it easier for you. And then you just, basically what you're saying is that this is the side that has more pressure.
Right.
The same way as if and I'm going to do this for you, if you have an increase in temperature. So remember, if I did this, CH4 plus O2 gives me CO2 plus H2O. Is this exothermic or endothermic? You guys should automatically know that. What kind of reaction is this? Combustion.
Right.
Exothermic.
Yeah.
Heat is released. We have done this before in 101. Where would I write the energy coming from, on the right or left side?
No, that's-
Right side. Plus 125 kilojoules or whatever, right?
Yeah.
So now I know that if I increase the temperature, increasing this, it's going to shift what? That way. I'm saying do the same thing. Just arbitrarily put pressure on the side that has more moles, and now you know if you increase it, it's going to go away from it. If you decrease it, it's going to come towards it. That's going to be the same thing we're going to do with the temperature as well, which is the third change. Is that okay?
So increasing the temperature and the combustion will increase
Shift it the other way.
direction of the reaction.
Just like a concentration. If I increase this, it's going to shift it this way. If I increase pressure, it's going to shift it away. If I increase temperature, it's going to shift it away. They're all exactly the same as long as you understand where the pressure and the, so the concentrations are obvious. I increase the concentration, that's the most intuitive. But if you know where the pressure is, if it's on this side greater or this side, wherever you increase it, it goes away from it. Wherever you decrease it, it comes back towards it. Same thing with the temperature. If I increase the temperature, wherever the energy is, it's going to go away from that because I'm adding more energy to it. If I pull out energy, it's going to move towards it. They're all exactly the same as long as you have the proper reference point of where the pressure and the energy actually are within the equilibrium. Does that make sense? That should make that easier. That's the hardest part about understanding. The concentration was very easy and intuitive. The temperature and the pressure, a little less, but if you know these things, then you know where the pressure exists and you just go away from it if you're adding to it, and you go towards it if you're taking it away, just like the concentration. Okay, with that, let me see, what's the next? So this is all needed for your exam on Tuesday. So let me see where we're at here. Okay, so what we did was, these are the effects on pressure. I'll pick this up, then we'll quickly talk about the effects on temperature, which I've actually already showed you, right? That will be a couple slides, and then we'll get into a new chapter, chapter 16, I think it is, but you'll only be responsible for this chapter and chapter 14, the kinetics, on Tuesday, a week from today. Okay. A couple of quick things I might as well bring up now that we're talking about that. You can use an 8.5 by 11 front and back paper that you could write on and bring into the exam. You need to have an 882 form Scantron, and of course a pencil, number 2 pencil for that. And then you're going to write right on the exam. Any questions about that? Most of you have had me, so you know. Any questions on that? You could ask more questions on Thursday if you need it. Okay. If you need that kinetics work.